Hello, this is History Lab. Today, we're going to learn about Archway. This lecture includes explain about Cosmos, Interchain, Cosmwasm, and Archway. To define Archway in a nutshell, Archway is a Cosmos native incentivized layer 1 blockchain built with Cosmos SDK and supports Cosmwasm. With that said, I think people who don't know much about blockchain might not know who Archway is and what it has to offer. So, in this lesson, we're going to take you step by step from the blockchain backgrounds to the Cosmos ecosystem to Archway. For those of you who are unfamiliar with blockchain, we'll start with the blockchain trilemma and the consensus algorithm, which is the background of blockchains so that you can understand the differences between different chains and the ecosystem that Cosmos and Archway are trying to implement. After that, we'll explain Cosmos and Cosmwasm so that you can better understand the foundation of the ecosystem that Archway is trying to implement. Finally, we'll explain what Archway is so that those who are new to blockchain can understand what it is. The subheadings are as follows. Chapter 1, Necessity of Cosmos. Chapter 2, Look into Cosmos Ecosystem. Chapter 3, Understanding Archway. In Chapter 1, I will explain you about blockchain trilemma, and then I will explain consensus algorithm, and then I will explain about necessity of Cosmos based on blockchain trilemma and consensus algorithm of Cosmos. What you're seeing in this picture is a site called CoinMarketCap, which shows the ranking of coins. These are all mainnet coins. If we already have Bitcoin and Ethereum, why are there so many chains? Let's take a look at the reason why. First, let's talk about the blockchain trilemma. The blockchain trilemma is a theory that one of the three characteristics of blockchain must be sacrificed in order to be stable, secure, and decentralized. And this blockchain trilemma was first used by Ethereum creator Vitalik Buterin as a classification criteria for blockchains. A node is a computer that is participating in a distributed ledger network. So first, I'm going to explain about security. Security is about ability to resist a large number of participating nodes trying to attack the chain. This means more than 50% of node is ideal, but less than 5% is problematic. The percent we're talking about here is a relative number, not an absolute one. So to be structurally secure, you need to be able to withstand an attack by a higher percent of node. Among the blockchain trilemma, the second feature, decentralization, is characterized as follows. Decentralized means chains can operate without trust in a small group of centralized actors. So when we talk about it being highly decentralized, we mean that there are multiple groups sharing the ledger in a decentralized form and operating outside of a small group of centralized actors. One of the biggest benefits of using blockchain from a user perspective is scalability. Scalability means that a chain can process more transactions than a single normal node can validate. High scalability, therefore, means that the chain itself can handle more transactions, allowing users to use decentralized apps at a lower monetary and time cost. Now that we've covered each of the characteristics of the blockchain trilemma, let's look at how blockchain works when certain characteristics are abandoned. So let's start with traditional chains. Traditional chains emerged early, so focus on decentralization and reliability that they didn't pay much attention to scalability. In the case of blockchains, the earliest chain like Bitcoin and early version of Ethereum fall into this category. For the second one, there are high TPS chains, where TPS is the number of transactions that can be processed per second. These chains sacrifice decentralization for speed. Decentralization means that there are fewer nodes that agree. With fewer consensus nodes, you get more speed without sacrificing stability. However, The small number of nodes sharing the ledger also means that attacks are possible with a small number of colluders. Examples include chains that fork Ethereum, such as BNB chain, which is powered by a famous exchange Binance, and Wemix and Clayton's. But they all have high TPS due to the small number of consensus nodes. So therefore, they have high scalability and they are highly secure, but they are not decentralized. For the last one, the multi-chain ecosystem. An example of this is the Cosmos ecosystem, which is we're going to learn about. And also it includes Archway. So Archway might highly scalable and decentralized, but less secure according to the blockchain trilemma. So when I say secure, I'm referring to the fact that multiple chains interact and are intertwined. So let me think about a percentage basis. If there is collusion on one chain and it affects the other chain, the overall stability is weaker. In response, Cosmos has also updated to version 2.0 recently, allowing subchains to operate consensus algorithms through Cosmos native coin, and is continuously developing to improve stability. The Internet of Blockchain is the goal of Cosmos. It is a form of chain that allows various chains to quickly interact in a decentralized environment by taking advantage of the blockchain trilemma. So in blockchain trilemma, Cosmos choose decentralization and scalability. Therefore, it can be said that we're continuing to develop the structure to make it more stable based on its advantages. Now let's talk about consensus algorithm. Being decentralized means that there is no centralized entity, but it also means that consensus is required. Therefore, unlike traditional centralized system in a blockchain system, each blockchain has its own consensus algorithm. First, a POW, proof of work, consists of guessing a specific secret value. All participants run the same program and try to guess the secret value with the same rules. If a spy, such as Red in this presentation, wants to try to manipulate, he has to do more computations to crack the secret and manipulate it first than the orange participants, who is alone and following the rest of the rules. However, guessing the secret value is like randomizing the number in a log. So as long as there are multiple participants, it is difficult for a single person like red circle in this picture to crack it first. And it is not practical to have hardware equipment, electricity, and other environments to manipulate a huge network like Bitcoin. And also, Bitcoin forms mining pools where mining is divided among many participants, and it is difficult for any one person or organization to win. So, as you see in these pictures, if these orange circles form a mining pools and try to unlock together, spy nodes cannot beat this lot of nodes in ecosystem. However, this forum was met with a lot of negativity for being extremely power hungry and destructive to nature, which eventually led to the creation of proof of stake. Instead of computation, proof of stake is based on the amount of stake in the network coin. These proof of stake use variety of techniques to create a reasonable consensus algorithm, such as reducing the stake of a target that makes a false proof, or randomizing the nodes participating in the proof of stake. Next up is PBFT, which is a solution to the age-old problem of the Byzantine general's dilemma, which is what to do when you have spies in a situation where you need to attack, at the same time to capture a castle. One way to solve this is to send messages back and forth to each other to agree on a time to attack. However, the number of participants is important here. If you have 3 participants and one of them is a spy, as shown in figure, you won't be able to tell which behavior is genuine if one of them deceives you. If there are 2 spies, it's hard to tell what's real even if there are 6 participants. if there are 3f plus 1 participants when f is a SPI, or a total of 4 participants when there is one SPI sends a manipulated message, so we will know who is the SPI, and we could catch the SPI. As you can see in this figure, there are 3 generals and 1 commander, and 1 general is a SPI. Let me think if I'm a general 1. 1 commander send me attack message, and 1 general send me attack message, but only 1 SPI send me retreat message. Therefore, I could figure out the general 2 is SPI. This means that as long as 3f plus 1 participants are guaranteed, we can say that BFT-like consensus schemes are valid even if someone commits fraud. Now that we've learned the consensus algorithm, so we can see what kind of format Cosmos is taking here. Cosmos uses the BFT-like Tendermint algorithm and uses POS staking method. Stake entities constantly send message back and forth to reach a consensus. And even if there are F spies, the chain is safe from manipulation as long as there are 3F plus 1 participants as shown before. Therefore, the consensus algorithm is irrevocable, meaning that once a transaction is created, it will never be revoked again. As a result, as you can see from the Cosmos homepage, Cosmos is highly scalable, although not scalable by the trilemma, and safe from manipulation if there are enough participants. You can also see that Cosmos chose the POS-based Comet BFT algorithm, which has the characteristics of BFT and POS described previously. This may seem complicated, but you can see that the advantage of staking Cosmos and using it for consensus algorithm and consensus through message is that we have a fast and manipulation-resistant form of consensus algorithm. As a result, fast and immediate finality is the hallmark of Cosmos consensus algorithm.